Hey guys, Miss A here again. Hopping on to make a video for you to help you with your daily skill number 4 from your math packet, which is going to be basically comparing rational numbers. You could also do this if you're comparing or having to put the numbers in order, because in order to order the numbers, you have to know how they compare, which number is greater than the other. Okay, so we're comparing rational numbers. Before we get started on actually doing that, I want to talk about a little bit of a vocabulary just so we know what we're dealing with. The first thing is a rational number. A rational number is any number that can be written as a fraction. And rational numbers can be fractions, they can be decimals, they could be improper fractions, mixed numbers, percents, integers, they can be positive or they can be negative. Okay, so rational numbers are basically almost any number you deal with almost. So again, any type of fraction, decimal, percent, integers, and of course rational numbers can be positive or they can be negative. Next thing you're going to need to know whenever you're comparing are the 3 symbols we're going to be using. Those symbols are the less than symbol. So this one, y'all might have heard it referred to before as like an alligator mouth. The alligator always eats the bigger number. In elementary, y'all probably learned it that way. So this is the less than symbol. That says whatever number is over here on the left is less than whatever number is on the right. The next symbol is the greater than symbol. So that means that any number over here on the left is greater than the number on the right. And then, of course, the equal to means the number on either side of the sign is equal to each other. Pretty self-explanatory. All right, so now we'll get into the steps. These are my personal steps. This is what I think you should do on any problem when you're having to compare them. If you follow these couple steps, it'll make it a little bit easier to know which number is greater than the other number. All right, so here we go. We've got 4 steps. So here are the steps to comparing rational numbers. Step number 1 is to convert everything into a decimal. You cannot compare 2 fractions that have different denominators. Denominators are the bottom numbers. If those bottom numbers are different, it makes comparing 2 fractions extremely difficult because the bigger that denominator gets, the smaller the pieces that make up the whole for that fraction, if that makes any sense. So the easiest thing to do is to convert every number into a decimal, which we'll see here in a little bit. Step 2 is to line up your new decimals on top of each other. So once you have them all converted, you're going to take them from being maybe side by side, you're going to put them on top of each other, lining up the decimals. Step number 3 is going to be to add zeros or repeating digits if it's a repeating decimal so that all numbers have the same place value. So if one number goes to the thousandths and one number only goes to the tenths place, you have to make everything go to the thousandths because that was the longest or the greatest place value. Okay, so make sure you add the zeros or repeating digits. Again, we'll see that later. And then once you've done those steps, then you're able to compare which number has the bigger value. All right, so here we go. Let's get into some examples. I'll keep this here above just in case you need it. We can refer back to it. But right now I'm just gonna kind of put it out of the way. All right, so here is our first example. We have the fraction 3/8. 3/8, and we have the decimal 0.5. And we want to compare which of these 2 values is bigger than the other. So again, as you remember from our steps that we just went over, step number 1 is to convert every number into a decimal. So one of them we already have, 0.5. The only thing I need to convert is the 3/8. So if you remember the video that I posted last week, come on, focus. I posted last week of how to change a fraction into a decimal. All we have to do is tie bow. Remember, where is it at? These things. Tie bow, top in, bottom out to change a fraction into a decimal, or you can do cowboy method. Cowboy goes in, horse stays on the outside of the house. So let's do that over here on the side. So we're going to top in, top number is 3, so it goes in, bottom number is 8, so it goes out, and then now we can do the division. So 8 is bigger than 3, so I know that can't go in, so I'll put a 0. And in order to keep on dividing, I have to put a decimal followed by a 0 because that doesn't change the value of the division problem. It still keeps it 3 instead of 30 by putting that decimal. Now we can drag the decimal up and then look at how many times 8 goes into 30, which is 3. which is 24. So we're going to subtract. We have to borrow, becomes a 10, that becomes a 2. And now I can subtract 10 minus 4 gets me 6. Add another 0. 8 goes into 60 7 times, which is 56. Subtract, again we have to borrow. We get 4. Still got a remainder, so I'm going to add another 0. Bring it down, and we know that 8 goes into 40 5 times, which is exactly 40, so we can stop. All right, so now we have 3/8 is equal to 0.375, and again, this number is already in a decimal. So step number 1 is done. Step number 1 was to convert every number into a decimal, so that part's done. Step 2 is to line up your new decimals on top of each other. So I'm going to take my new decimal of 0.375, 0.375, and my already given to me decimal 0.5, and I'm going to line them up. So now they're on top of each other. Decimals are lined up, and I'm keeping my place values in line with the one above it. Step number 3 is to add zeros or repeating digits so that all numbers have the same place value. So right here we can see that my first decimal goes to the tenths, hundredths, thousandths, but this decimal stops at the tenths. So because thousandths goes out the longest, my other number has to go to the thousands as well. I'm not going to put a repeating number because this decimal was not 0.5 repeating, so I can just put 2 zeros. And then now I can compare the two decimals. I have 375 thousandths or 500 thousandths. So now you can see which one is greater, 375 or 500. 500 is bigger than 375, so that is my bigger decimal. So here, it might be helpful to also write it above it so you can actually see. We said that the 0.5 was greater, so I need to put the less than symbol like that because this says that 3/8 is less than 0.5, which is exactly what we have here. The biggest issue I have, the biggest mistake I see kids make whenever they're comparing is they're not adding those zeros and they're looking at these two decimals. And if you're looking at it quickly, not really paying attention, you're going to tell me that 375 is bigger than 5 because that is the case. But when you look at it according to place value, the 3 is in the tenths place and the 5 is in the tenths place. So that would actually make the 5 the bigger number. But by adding those zeros and making the numbers look the same, have the same place value, makes it a little bit easier to compare. You can see that 500 is definitely bigger than 375. Okay, and again, if it's helpful to you, just think of the alligator. The alligator eats the bigger number, which is the 500 instead of the 375. All right, let's do a couple more. Number 2 is going to be 1/3 and 0.3. So 1/3 and 3/10. Separate those so we don't get them confused. 1/3 and 0.3. So again, we want to do step 1, which is convert everything into a decimal. That one's already done. All I have to do is convert this one. So top number goes in, bottom number goes out, and I can divide. 3 goes into 10 3 times, which is 9. Subtract, you get 1. Add a 0. 3 goes into 10 3 times, which is 9. Subtract, you get 1. And then we notice that I'm keep on getting a remainder of 1, and I keep putting a 3 on top. So I really don't have to go any further. I can stop. My decimal is not 0.333 or 0.33. My decimal is 0.3 repeating. So this one is 0.3 with a repeating bar on top. So that was step 1. Step 2, again, referring back here. Step 2 is to line up your decimals, and then step 3 is to add zeros or repeating digits. So I'm going to line them up, get 0.3, and then I get 0.3 repeating. So you might look at this and say, well, I don't really need to, I don't need to add any decimals or repeating digits because they're already look the same. 0.3 is equal to 0.3, but that's not the case. We still want to expand these, okay? So 0.3 ended. That was a terminating decimal. So in order for me to add a value that doesn't change the value of 0.3, I'm going to put a 0. because that one did come to an end, but this one was 0.3 repeating. So I'm not going to put a 0, I'm going to put the repeating digit of 3. And now we can see we've got 30 hundredths or 33 hundredths, so we can tell that 33 is bigger or greater than the 30. So this was the 0.3 repeating, so 1/3 is greater than 0.3. So it's kind of tricky on those repeating decimals. You're going to think that they're the same, but that repeating decimal means it keeps on going. So you have to put that repeating digit and then add that 0 on the other one. So you can clearly see that this one is the greater value. 33 hundredths is bigger than 30 hundredths. All right, number 3 is the value of 1 and then 7/5. All right, so let's go ahead and do the same thing like we did before. We're going to convert everything into a decimal. Now, technically, this one isn't a decimal. This is a whole number, but I can make it a decimal by putting 1.0. Anytime it's a whole number, just put a 0.0 and it makes it into a decimal for you. And now we're going to convert this into a decimal. Top in, bottom out. All right, 5. One mistake I saw people make on one of the parents sent me a picture of their homework completed, and they made this mistake. The kid set it up completely correct, put the top in, bottom out, put a decimal and a 0, and he went ahead and just said, okay, well, he was able to skip count by 5s. He skipped count by 5s and saw that 5 goes into 70 14 times. So he put the 14 here. But if you look at this, you should have done the first step of 5 goes into 7 one time. So the 1 would have actually gone above the 7. So yes, sometimes it's really nice to just skip count whenever the number is small enough, but I wouldn't do that in this case. So top in, bottom out, and take it one number at a time. 5 can go into 7 one time, which is 5. Subtract, you get 2. And then you can add a decimal and a 0 and bring that decimal up and the 0 down. And then 5 goes into 24 times. So you get 1.4. So line up your decimals. So we had 1.0 was here, 1.4 was here. Now this one, because both of them they have the same place value, both of them stop at the tens place, I don't have to add anything. I can just compare. You have 1.0 and 1.4. So the greater value is 1.4. So 1, let's put it actually between the problem. 1 is less than 7/5. All right, and then the last thing I want to talk to you about just really quickly is comparing two fractions. Of course, let me round down first. 3/5 and, oh no, sorry, I don't want to do that one. My bad. 1/2 and 2/3. So when you're comparing two fractions, like I mentioned earlier, when those denominators are different denominators, you cannot compare and say 2 is bigger than 1 or whatever the case may be. You have to do either the steps that I talked about earlier of converting everything into a decimal and then lining up your decimals, comparing them from there, or you can actually get a common denominator. So I'm going to show you that method, and then I'm going to show you a shortcut to it. So common denominator allows you to compare the two fractions easily. What I mean by that is if I had the fractions, for example, if I had 1/5 and 3/5, I could easily compare those two fractions because the denominator is the same. 3/5 is clearly bigger than 1/5. When the denominators are the same, you can do that. So you could just clearly say 1/5 is less than 3/5. But over here, my denominators were 2 and my denominator was 3. So those are different, so I cannot compare them quite as easily. So what we're going to do is we're going to get a common denominator. A common multiple between the two of them is the multiple of 6. So you could take 1/2, get a denominator of 6 by multiplying by 3. 2 times 3 is 6. So multiply this times 3 and you get 3. So 1/2 is equal to 3/6. And then I can take 2/3 and get a denominator of 6 by multiplying by 2. Do the same to the top and you get a numerator of 4. So then we could compare. The 1/2 is now equal to 3/6, right here. The 2/3 was equal to 4/6. So then you can see that, okay, now they have the same denominator. 4 is greater than 3, so this has to be the greater fraction, okay? So that is what you actually are doing. That's the process of getting a common denominator. One little shortcut we could do to make it a little bit easier is what's actually known as the butterfly method. I know some teachers kind of frown upon this because it's kind of taken away from that common denominator part, but I'm just going to show you this little trick, okay? So we have the fractions. Kind of separate that. We have the fractions 1/2 and 2/3. One thing we can do is just butterfly, cross multiply. So I'm going to multiply those two fractions those two numbers together. 1 times 3 gets me 3, put it up here. And then 2 times 2 equals 4. So you can see that my numbers I put on top here were actually my numerators when I got my common denominator. So I'm just taking out that step of actually getting that denominator of 6, because I can understand that it's going to be 6 by multiplying those two. So once you have 3 and 4, you can compare, okay, 3 is less than 4, so that means this fraction has to be the same as well, which is exactly what we got down here by doing the longer method. All right. So again, you could have also just simply compared them, got them all into decimal. 1/2 would be 0.5. 2/3 would be 0.6 repeating. No really need to actually extend them out because 5 is less than 6. So you can see that's the bigger decimal. So you could have done it my way of the 4 steps that we had listed out earlier. Perfectly fine. But when it's 2 fractions, the easier method sometimes is just to do a little shortcut of butterflying, cross multiplying. Basically, like I said, it's getting a common denominator. But I hope this video was helpful of comparing irrational numbers, determining which one is bigger than the other. Remember our 4 steps. Convert every number into a decimal. Line up your decimals on top of each other. Add your zeros or repeating digits so they all have the same place value. Once you have that, you can compare the place values and determine which one is greater than the next. All right. Hope this helps, guys. Stay safe. Miss y'all.